We're now going to look at the effects of finite gain on our amplifiers. Alright, so let's say that we have a non-inverting amplifier. We put our input in on the non-inverting terminal of the op-amp. We put our feedback around the inverting terminal of the op-amp. And let's label this node A. So we have a feedback resistor RF, and we're dividing that voltage with the resistor R. Now, since we have a finite gain amplifier, we know that our output voltage is equal to A of S times the V plus terminal minus the V minus terminal. In other words, A of S, in this case, times VI minus VA. And A of S, we know, is an op-amp with finite gain, so it has a finite DC gain and one pole frequency. Alright, so what we want to do is find an expression for the gain, V out over V in, as a function of frequency. Alright, and one way to do this is with brute force. So let's try that. We're going to go to node A and do KCL. And if we do this, we see, of course, that we have V out minus VA divided by RF is equal to VA divided by R. Manipulating this a little bit, we see V out over RF is equal to VA times 1 over R1 plus 1 over R2. Substituting an expression for VA, so we can rearrange this expression and say VA is equal to VI minus V out divided by A of S. Substituting this in and doing some algebraic manipulation, we find that V out over VI with respect to S is equal to 1 plus R2 over RF over R1. And I keep doing this. RF here, R2s are supposed to be RFs. And we don't have an R1, we just have an R. One plus RF divided by R over 1 plus A of S times 1 plus RF divided by R. Alright, so now let's substitute our expression for A of S into this expression that we just derived. And we would find, if we did this, that V out over VI with respect to S is equal to 1 plus RF over R times the quantity 1 divided by 1 plus S divided by A naught times omega H, the pole frequency, times R divided by R plus RF, that quantity. Alright, now if A sub 0 is big, so we can say the limit of VO over VI of S as A goes to infinity is equal to 1 plus RF divided by R. Now this is the expression that we expect to see for a non-inverting amplifier. In the next part of the lecture, we're going to look at what happens at a more elegant solution using feedback analysis to find this answer.